Hey class, we are continuing on with our integration unit. I'm going to show you another new method. This is going to be like undoing a least common denominator. So normally, if I were adding two fractions together that are rational expressions, let's say I have 3 over x plus 1 and x over x minus 2. If I'm going to add these two things together, I have to get a common denominator, which I would get by just kind of smacking those two things together, and then I would multiply each numerator by the other one, something that you would have done in Algebra 2. I would then distribute, combine like terms, and simplify, and you would get something that looks a little bit like the problem I have over here. So we have to undo that because right now, integrating this problem looks pretty gross. But if I can split it up into two basic problems like this, these would be easy to integrate because these are fractions with an x in the denominator. It's giving me like ln vibes. Pretty simple. So that's what we want to do. I'm going to erase this over here. So the question is how do we get that to happen? There are multiple ways that people think about this. I'm going to tell you the way that I do it. If you're practicing on Delta Math, you're going to see a slightly different way on there. I think the way I do it is easy, but everybody's different. So the first thing that I need to do is to factor the denominator. So that's going to be a giveaway when you are doing these kinds of problems, is that you're going to see that the bottom can be factored. So sometimes it could be a trinomial. It could be a difference of squares. It could just be a GCF, really like anything goes. So go ahead and take a second and just factor that denominator. I'm going to do that as well. Okay, so I went off to the side there real quick and just factored that out so I wasn't wasting your time going through that. I know everybody factors trinomials a little bit different. I've gotten into the habit of using Martinsville method, but you can do whatever you like to factor that. Some people do guess and check, whatever you want. So once that is factored, here's where these steps are going to come into play. So what I need to do is find the zeros of those factors. So I'm going to kind of color code this. I think that will help. So I've got this one and do some purple. So this factor has a 0 of -1. And this factor has a 0 of 1/2. I am going to plug -1 back into the problem. Now I don't want to plug it back into its own factor because that would give me 0 and that's not going to help me. That's why it's a 0. So I'm going to plug it back into everything else. So 5 minus -1 would be 6. 2 times -1, -2 minus 3, so it'd be -3. That gives me -2. That's nice. And I'm going to take that -2 that I got, and I'm going to put it over top of the factor that gave me that answer. So now I'm going to come over here with the 1/2 and I'm going to plug it in to everything else. So, great, so we have 1/2, so 5 minus 1/2 would be 4.5. So let's leave that as a fraction and we'll say 9/2. And plug that into the denominator. That's 1/2 plus 1, so 3/2. Let's do a little leave, change, flip, reduce, 3. So I'm going to take that 3 and put it over top of its 0. I do find it helpful to kind of work from left to right. I focus on, the first factor first, then the second one, because it's easy to get jumbled and kind of get your pieces crisscrossed. But whatever factor gave you that number when you plugged it in, that number goes in the numerator. I often get asked, well, what happened to the 5 minus x? It's gone. No, we don't need it anymore. If you were to add these two fractions together, get a common denominator, distribute and combine like terms, it would give me this. And if it doesn't, then you've messed up somewhere. Now that I have that split up, I'm just going to integrate it, and that's going to be a pretty simple integration problem. Reviewing some stuff that we talked about with basic integration. So I'm just rewriting this broken up to -2. And now I have two problems that I'm going to integrate. So this is giving me like u sub ln. There's nothing in front of the x, so I can actually skip the u sub part and just do ln of x plus 1. Keep your absolute value. This one, though, does have a 2 out in front of x, so I'm going to have to account for that 2 by multiplying by 1/2. So 3 times 1/2 be 3/2. When I'm running out of room. And then I need a plus c. Okay, so that would be my answer. A couple of things. Watch out for if you have a negative in front of x, because that will change it to minus. Not so much this problem, but sometimes when they're very similar, like your terms are very similar, they'll use those pre-calc condensing and expanding rules. So just keep an eye out for that, especially if it's like a multiple choice question. I think I actually have one of those next. But these are the steps. Now, sometimes your numerator doesn't have an x in it, and that's okay. You'll just leave it alone when you're plugging back in. I think I have one of those next as well. Just keep in mind, partial fractions is going to be great when the bottom can be factored. That could be a GCF, it could be a difference of squares, it could be a trinomial, anything that can be factored. So this is actually an AP type problem. And I'm just going to work through it using the partial fractions method. And sometimes the AP test is generous enough to have the denominator already factored for you. So that will be a giveaway if you see that the denominator is already factors. So that would be a plus. But this one is another trinomial, so I do need to factor it. So I'll start there. A little bit easier of a problem than the last one. What can we multiply to get 8, but add to get -6? -4 and +2. Nope, that doesn't work. -4 and -2. There we go. So multiply to get +8 and add to get the -6. So now that that's factored, I have to find my zeros. So once again, I will color code. If that helps you, feel free to break out your color pens or highlighters. So I need to find the 0 for this, which would be 4, and the 0 for the other factor, which is 2. I'm going to plug 4 back into everything that's left. So this time there's just a 1 that's already there in the numerator. And then when I plug 4 into the denominator, x minus 2, 4 minus 2 would be 2. I'm going to put that 1/2 over top of my denominator, which, because this is a fraction, it would probably look better if I just keep it off to the side. Doesn't doesn't look quite as gross. So you could do that. And then when we plug 2 in, I still have 1 and -2. Okay, so now I need to integrate both of these pieces. So I have 1/2 integral 1 over x minus 4 and a -1/2. Okay, so 2 simple integration problems where we're going to have a 1/2 out in front of each one. And we just have 1 over, x minus 4, so that's going to be an ln. And we have ln x minus 2 plus c. Okay, so we are finished. And if this were just like practice on Delta Math, or if it was a free response question where you're just writing out your answer, this is right. But you'll notice that this question is multiple choice, and the answer that I got is not on the screen. That does not mean that I'm wrong. It just means that this problem went a little further. So you can actually simplify this because we have subtraction. If you think back to pre-calc, we can change that to division. So my answer would actually be A, because I'm doing x minus 4 and then divided by x minus 2. So we're factoring out that 1/2, and then we're using that condensing rule. And that's kind of where, on the AP test, if you're taking that, where they'll kind of get you sometimes, is you actually have the right answer, but you just have to know how to simplify it. And a lot of times it goes back to those basic algebra or pre-calc skills. That's really it. There's not a lot to it. As long as you can factor and you know the steps, this is probably one of the more simple methods, definitely one of the easier ones to identify. And that's it.